All right, 4.2, modeling and density. This is where we're going to use our application of volume. So some vocabulary. Density is the amount of matter that an object has in a given unit of volume. So we're going to be looking and using the volume, and we're going to be using the mass to find the density. Density equals the mass divided by the volume. So we are going to look at our first example. We're going to determine which type of wood is more dense, Douglas fir or American redwood. We are given some information. We're given the diameter of a Douglas fir, the height, and the mass. We're also given the American redwood, the diameter, the height, and the mass. So I've kind of written out a few steps here. The first step is to determine the volume of each log. So to be able to determine the density, we need the volume and the mass. They gave us the mass, so we got to find that volume. So we are going to find the volume. It's the area of the base times the height. Now, when you're talking about a log of wood, because it's for each log, those are circular in the base. They look like cylinders. So if you think about it, a log kind of looks along lines like this. So it's cylindrical on the ends, or cylindrical in shape, which means the ends are circles. So this, for our area of our base, is going to be pi r squared. Now notice, they gave us the diameter. So if the diameter is 6, that means the radius is 3. And on this one, for the American redwood, if the diameter is 8, the radius is 4. And we have the height. So we're going to use our formula, and we're going to say for the Douglas, to find the volume, it is pi times r, which is 3 squared, times the height is 17. And when we look at that and we multiply that all together, 3 squared is 9 times 17 gives us a total of 153 pi centimeters cubed. Now, we're going to estimate that to a rounded decimal, so we're going to take that 153 and multiply it by pi, so that gives us a total of 480 centimeters cubed. Make sure you're checking these on your calculators so you know how to use them. And then we need to find the American redwood. Volume equals pi times the radius, which is 4, times the height, which is 12. When I multiply those values together, 4 squared is 16 times the 12. That gives me 192 pi centimeters cubed. And then when I round that out and multiply this times that 3.14, I get approximately 603 centimeters cubed. Let me see if I can write this side just a little bigger. So now I have the volume of both. So to find the density of each, let's do the density. Let's do it in purple so it stands out. So the Douglas density says take your mass, that 254, and we're going to divide it by the volume that we found. So 254 divided by the volume of 480, and that comes out to be approximately 0.529, and that is kilograms per centimeters cubed. Those are our units. Mass was in kilograms. All of our measurements were in centimeters. And to find the American, we take its weight, that 271, and we divide it by its volume of 603. And when we do so, we get an approximate 0.449 kilograms per centimeters cubed. So when we look at which one's denser, which number's bigger? Douglas fir has a bigger number, so that means the Douglas fir has a bigger density. So it is denser. Now, what does that mean? What does it mean to be denser? That means if you took the logs and they both weighed the same size, the So we have a piece of Douglas fir and a piece of American redwood, and they're the same size. That means the Douglas fir would actually weigh more than the American redwood. So moving on, we have some other types of densities that we're going to talk about. The next one that we're going to talk about is the population density. So we want to talk about this population density. Population density is population divided by the size of the area. So the population of an area divided by the size of the area. The state of Vermont has a population of 626,000. The Vermont territory can be modeled as a trapezoid, shown below. So here it is. Each unit on the coordinate grid represents 1 mile. Find the approximate population density of Vermont. Well, they already gave us the population. So the part that we actually have to figure out is the size of Vermont. We need to figure out what the area is of Vermont. So we are going to find the area of this trapezoid. Now, that requires us to remember our formula. Area equals 1/2 base 1 plus base 2 times the height. This is going to help us find the size of Vermont. We already have the population. So if we're looking, remember, these are each square miles. This is going by 20 units, so 5 of these made 100. So this base here is 40. The top base goes over 4 marks, so that's 80. And my height, there's 120, 140, 160. So 1/2, what did we say, 40 plus 80 times 160. And that's going to give me my area. When you multiply these all together, that's 9,600 miles squared. Because remember, each of these meant, and it was measured in miles. So, to find that population density, according to my rule up here, I take the population My population is 626,000, if I can talk, and divide it by your area, that 9,600. When you divide that in, you get approximately, and remember, you can't talk about half a people. So that's about 65 people per miles squared, which is actually not bad. 65 people live in a square mile. That's not a bad area. So we have one last type of density we're going to talk about. So we've talked about the density, like dealing with weight. We've talked about population density. And now we're going to talk about density as far as energy. So let's see. Move the little marker over so it stays put. So we have the measures of energy. Energy content of fuel is BTUs per unit of volume. So a spherical tank is filled with gas. It has the dimensions shown. Find the number of BTUs produced by 1 cubic foot of the gas. Round to the nearest BTU. When the tank is filled with natural gas, it provides 116,151 BTUs. So first things first, we're going to find the volume of our gas tank. So volume of a sphere. Volume of a sphere. 4/3 pi r cubed. Now, it's been a while since we talked about volume. We did surface area. We haven't really talked about volume. That was something we learned in Math 2. Here, they gave me the diameter because it goes all the way across. Since the diameter is 6, that means the radius is 3. So we're going to plug that in. Now, from here, you're going to plug it into your calculator. 3 squared is 27. Cubed is 7. And then you're going to multiply by 4, divide it by 3. And that is going to give you 36 pi. That's the volume. To find the BTUs that are produced, I'm going to take the gas and divide it by the volume. So my BTUs is my amount of gas divided by the volume. So when you divide this, you want to make sure that you multiply 36 times that 3.14, and you get approximately 1,027 BTUs. These are word problem examples. These are applied. These are modeling and density. They're very, very important. So please take good notes. Write it all down so we can practice some more.